The example 5.3. Hydrogen in a pressure vessel, take note of that, that's a critical information, has an initial temperature of 55 degrees C. So we have a temperature of 55 degrees C, which we need to convert to Kelvin. 55 plus 273, giving us 328 Kelvin at an initial pressure of 3.6. Take note of that, 3.6, that is megapascal. Megapascal. Until if the hydrogen is cooled until the pressure is, so we have, that means we have a P1, and then we also have a P2. So we have a P2, which is 1.8 megapascal. What is the final temperature of the hydrogen? So that means this becomes T1, and then T2 is unknown. T2 is unknown. And so since it's a pressure vessel, what that infers is for a pressure vessel, the volume remains constant. So we've seen pressure has changed, the temperature has changed, but the volume remains constant. And then let's go back to from the previous class we've seen, or previous slides, we've seen the fact that your P1V1, T1, this is one of the PV relationships we've been provided. P2V2 equals T2. But remember that our V values are constant from there, V1, V2. So we can say that goes out, and then we are left with P1 V1 equals P1 T1 equals P2 T2. Let's take that on, and then we can remember we have T1, we have this, we have that, we're looking for that. So we can make T2 the subject of the formula, and then we are left with P2 T1 over P1. And then we can, since the units for P2 and P1 are the same, we don't need to convert. It's 1.8 MPa multiplied by our T1, 328 Kelvin, divided by 3.6 MPa. That cancels out. If you divide that, we should have T2 equals 590.4 Kelvin, 3.6, which should give us 164 Kelvin. So we can either leave it this way, or just to continue with the way the question was asked, we can convert our T2 to Celsius, which is simply 273. We just say our 273, it's 273, rather 164 minus 273, it should give us minus 109 degrees Celsius. Let's look at another example. A gas occupies a volume of 0.18 meter cube. So we have a volume 0.18 meter cube. When is gauge pressure? It's important to take note of that. Gauge pressure, so let's call that PG. PG equals 1.2 megapascal. And then we said at that point the temperature is 15 degrees C, which is same as 288 Kelvin. The gas is then compressed until it occupies. So in that case, there's a volume change. So we then say we have V2. 0.096. Remember, it's compression. So if it's compression, the volume is reducing at 173 degrees C. So that means we have T2. So that means we have T1 and T2, which is 173 degrees C. T2 is 173 degrees C, and then convert to Kelvin. That should give us 446 Kelvin. So we have we have V1 T2, we have a PG, we have a T2. So what is the new gauge pressure of the gas? The new pressure of the gas. So that's what you're looking for. But remember, we've been given an atmospheric pressure as well. So we've been given atmospheric pressure, but we are looking at, so this will be the PG1. We are looking for PG2. That's what you're looking for. Let's plug in what we've got, and then we'll see how we can find our unknown. But recall, from one of the early classes, we've said absolute pressure equals your gauge pressure plus atmospheric pressure. So based on that, we can say 1.2 times, remember what we've got is megapascal. Let me quickly emphasize at this point. So 1 megapascal is equal to 10 raised to power 6 Pascal, which is same as 10 raised to power 3 kPa. So same as that. So having said that, and we want to ensure we have consistency. Remember, this is kPa, that is MPa. So we want to ensure consistency. So we take this to kPa, 10 raised to power 3 kPa plus 98 kPa. So our absolute pressure then becomes 1298 kPa. We can leave it as kPa 1298 kilonewton per meter squared. Our working PVT expression, remember in this case, volume, as we see change in volume, we are seeing change in pressure, we are seeing change in temperature. So it then means that this equation we hold for this expression will hold for this particular question. So, and then remember, what we're looking for is the new gauge pressure. And then so that means you're looking for the new P2. We are looking for P2. Remember, in this case, P, we've taken that as our P1. So P2, let's make P2 the subject of the formula. From here, we should be left with P1 V1 T2 over T1 V2. But remember, we are looking for over T2. But in this particular case, our P, even though we started with PG1, but our pressure is actually absolute pressure. So this means that absolute pressure is what we plug in here. So this would be, we can then say this is our P1. So if we plug in, if we put that in, 1298 kilonewton per meter squared. Remember, we said since our volume is in meter cube, it's essential to convert our pressure to a unit that has meter squared in it. So times 0.18 meter cube. We've been given that 0.18 meter cube times 446 Kelvin. Kelvin divided by 288. That's at T1, 288 Kelvin. And then the second volume, 0.096 meter cube. Meter cube cancels out, and then the Kelvin should cancel out as well, and then we should be left with the Newton meter squared, the kilonewton meter squared. P2 then becomes 104,203 27648 kilo Newton per meter squared, which gives us 3768.93 kilonewton per meter squared, or kilopascal. Remember, this is Pascal, so we can have that. And all, but our question is, what is the new gauge pressure? So P2 that we've calculated is absolute. P absolute. So going back to what we've got, PG is P absolute minus P atmospheric pressure. So our new volume would then, our new pressure rather, would then be 3768.93 minus the atmospheric pressure 98, which gives us 3670.93 kilopascal, which is same as kilonewton per meter squared, which is same as 3.67 megapascal. Let me write this here to be clearer, megapascal. All right, so that's where we'll stop for today. I'll be posting some extra questions for you to practice, and then I'll also have some written out solved questions for you to look through. All the best. See you in the next class.